Videos earlier in the playlist looked at number sets, and in particular we looked at natural numbers, and these are numbers which start at 1 and go to 2 to 3 to 4 in steps of 1 and so on. Whole numbers goes from 0, 1, 2, 3, 4 and so on. Integers, well, they go from 0, 1, 2, 3, 4 in the positive direction, -1, -2, -3 in the negative direction. And of course we also looked at rational numbers. Now, rational numbers are numbers that can be expressed as a ratio of integers. And if we have a look at some examples here, we've got 0.5 is 1 over 2, which is a ratio of integers. -4 is -4 over 1. 6.5 is 13 over 2. All of these are examples of numbers that can be expressed as a ratio of integers. Let's take some examples of these numbers, and here I'm going to look at 1 and I can see it belongs here on the number line. 3, well, that belongs at this position on the number line. -3, well, that belongs here. Here we have a half, and that actually belongs here on the number line. And of course -4 over 1 is actually -4 on the number line. 13 over 2 is 6.5 on the number line. So we can see all of these numbers that are natural numbers, whole numbers, integers and rational numbers all have a position on the number line. Here we can see we have a right-angled triangle, and according to Pythagoras, a squared equals b squared plus c squared. If I make b and c 1, we end up with a squared equals 1 squared plus 1 squared, and a squared therefore equals 1 plus 1, so a squared equals 2. If I take the square root of both sides, a equals the square root of 2. So this here is the square root of 2. Now here you can see I've taken a snapshot of the number line and made it a lot bigger so we can easily see it. If you look at the number line, you can see I've drawn a triangle here, and it's this triangle. So we should know that this length here is going to be the square root of 2, because that's what I proved a moment ago using Pythagoras. So this particular point here that I'm now pointing to with this arrow is obviously the position on the number line of the square root of 2. So the square root of 2 has a position on the number line. Using the number line as our reference, we should clearly see that the square root of 2's position is not a natural number position. It is also not a whole number position. Likewise, it is clearly not one of the integers that appears on the number line. A question to ask: is there a ratio of two integers that equal the square root of 2? Now the answer to this is no. The square root of 2 is not a natural number. It's not a whole number. It's not an integer. It's not a rational number. Remember, if it is not a rational number, then it cannot be a number that either recurs or repeats. Here's an example of a recurring number. Here's an example of a repeating number. Here are some values that are used for the square root of 2. 1.414, and we can also have it more accurately expressed as 1.4142 or 1.41421. Now, all of these are values of the square root of 2 that we can use. It depends on how accurate we want our final result to be. Clearly, the more decimal places we have, the more accurate our final answer will be. If we consider this last value, the one that's more accurate, and we look at this area, i.e. we look at the fractional bit of the number, it does not repeat. In other words, there's no repeating patterns here. It doesn't recur. If we have a look at this example, we can see this goes 234, 234, 234. That has a repeating pattern. This does not have a repeating pattern. The square root of 2 is an irrational number. You will have seen this diagram in previous videos, where this area here represents the natural numbers, this the whole numbers, this the integers, and this area represents the rational numbers. And of course the rational numbers contains within them the integers, the whole numbers, and the natural numbers. Now the square root of 2, which is an irrational number, does not belong anywhere in this area. It doesn't belong to the rational numbers, the integers, the whole numbers, or the natural numbers. Irrational numbers occupy their own space, as you can see here. So we have a different area for irrational numbers. The square root of 2 is an irrational number. Pi is an irrational number. So these two would appear here on the actual diagram in this area. All of this diagram represents real numbers, and you often give real numbers this particular symbol here. So natural numbers, whole numbers, integers, rational numbers, and irrational numbers are all examples of what we term real numbers. Check out the supporting website for these videos, and also consider subscribing to the YouTube channel and get an automatic update every time I upload a new video. Also consider subscribing to the Google Plus circle that relates to these videos.